So yeah, we'll cover some basic concepts. Uh, so first we'll cover two connected ideas. What is a component and how to design classes, design class-based components. Uh, I'll keep it simple and try to use an example throughout. So what is a component? So component is a part of a software system that has one clear job and can be used without needing to know its internal details. Think of it like a building block you can plug into a larger system. So a good component has a clear responsibility and a clear interface, meaning how other parts use it, and hidden internal details so it can change without breaking everything. So why it matters? So components help you build systems that are easier to understand, test, reuse, and change. So without components, you usually end up with one large, messy code base where every change breaks something else. Um, Object-oriented view. So we'll discuss difference between object-oriented view and traditional process view. So object-oriented view is uh, it's a component. A component is often built from classes and objects without working together. You think it in terms of objects with responsibilities. So that's basically object-oriented view. Traditional or process view is basically a component is often a module, so function group or procedure that performs a task. Think more in terms of inputs, processing steps, and outputs. So that's traditional view or process view. So both views are trying to do the same thing. The organized software is into meaningful parts. They just describe the parts differently. Like for example, take a shopping website. So like a component would be payment component. So in object oriented view, you might have classes like payment service to handle charging, payment method to represent card or wallet, a receipt to store the result. So the component is small group of classes that work together to complete payment. Whereas in traditional or process view, you might see it as a set of functions like validate card, charge card, create receipt. So the component is a module with procedures that process inputs and produce outputs. So either way, other parts of the system should only see the interface like pay, amount, comma, payment info, return success or failure. They should not need to know how payment works inside. And we have design class based components. So when we design class based components, we are deciding what classes are inside the component, what each class is responsible for, what methods each class exposes, and how other components will interact with it. So the main goal is simple: make the component easy to use and hard to misuse. So some of the principles and guidelines is have a clear responsibility. Each class should have one main job. So if a class is doing too many jobs, it becomes hard to change and hard to test. And also have a clear interface, you know, by hiding internals. Expose only the methods others need. Keep the internal helper logic private. And design for change. So assume requirements will change. Classes should be organized so changes stay local, and also keep it readable. If people cannot understand the component quickly, it will be used incorrectly. Uh, so a component is a clean building block with a clear job and clear interface. In object-oriented design, and components are usually built from classes that each have clear responsibilities. Uh, and the best designs keep things simple, readable, and easy to change. So that's about components and class-based component design. Next, we have cohesion, coupling, and how to do component level design. So we'll cover two things that decide whether your code stays clean or turns into a mess, uh, by cohesion, coupling, and a simple way to conduct component level design. Uh, we'll use an example, online store example for it. So cohesion means how well things inside a component being belong together. So high cohesion is good because component has one clear purpose. So an example is like, for example, a component called order component handles only order related tasks like create order, update order status, calculate totals, apply cancellation rules. Everything inside supports the order purpose. Low cohesion means the component has mixed responsibilities that do not belong together. So if a order component also sends marketing emails, formats UI screens, writes raw database queries everywhere. Now, if it is doing too many unrelated jobs, that makes it harder to change and harder to test. And then we have coupling. So coupling means how dependent one component is on another. So low coupling is good because components can change without breaking the others. Like for example, order component talks to a payment component through a simple interface like charge amount. So order component does not care how payment works internally. So uh, high coupling means components are tightly connected and depends on each other internal details. Like example is, your order component directly reads payment components internal database tables or private variables. Now if payment changes, order breaks. That is high coupling, and it makes maintenance painful. uh, so aim for high cohesion inside a component and low coupling between components. Next we have conducting component level design. So component level design is just a clear process of turning requirements into clean components with clear responsibilities, interfaces and dependencies. So first is, there's a workflow for it. First we have, you decide what each component is in charge of. Like order component is in charge of order creation, status, totals. There are like other components with each has its own uh, responsibilities. So you identify the responsibility. That's the first step. And second step is define interfaces. So decide how other components will use it. You are using a small set of public methods. Uh, so interfaces should be simple, and other components should not need internal details. And then you check the dependencies. So make sure dependencies are reasonable and not tangible, tangled. So clean dependency direction is, order component calls payment component and notification component. Payment component should not call order component back in a messy loop unless it's truly needed. So you look for warning signs like circular dependencies, too many dependencies for the components reaching into each other's internals. So that's few warning signs. So a high cohesion keeps component focused, low coupling keeps components independent. When you design components, you define responsibilities first and then clean interfaces and check dependencies so your system stays stable as it grows. So that's about these three topics. Um, Next we have UX design elements and UI evaluation. So we'll cover these two topics. So first we have core UX design elements. For that we have first information architecture. So this is how you organize content so users can find what they need without getting lost. So it is about structure, labels and navigation. Like for example, in a tutoring scheduler, the main tasks are find a tutor, book a time, manage your bookings. Good information architecture might use simple sections like home, find tutoring, my sessions, help, these kind of things. So that's the information architecture. And then we have interaction design. So interaction design is how the users move through tasks step by step. It focuses on flows, buttons, feedback, and what happens after each action. So booking a session should feel like a smooth flow, like you choose a course in a tutoring website. You choose a course, pick a tutor, you select time slot, you confirm booking. So after confirmation, the system should show a clear message like booked for Tuesday 10 a.m. and it sends a confirmation. If the user clicks book and nothing happens, this is a poor interaction design because users will not know if it worked. So that's interaction design. Usability. So usability is how easy the system is to learn and use. A usable interface is simple, consistent, reduces mistakes. In a scheduler, usability means clear labels like book session instead of vague words like submit or something like that. Consistent buttons and layouts on every page, and preventing errors like blocking double booking and showing helpful messages. Good usability is not about making things fancy, it's about making tasks easy and predictable. And then we have visual design. So visual design is the look and feel. So it helps users scan information quickly. It is about spacing, font sizes, contrast, consistency. So if like for the scheduler website, if available times are displayed in a clean readable blocks with a constant contrast, we can pick a time fast. So if everything is in the same color and same size, users cannot easily tell what is clickable or important. So visual design supports clarity. Next we have UI evaluation and accessibility, usability. So a prototype, we have prototype review. So prototype review means checking the UI early before it is fully built. It can be a paper sketch or clickable mockup. The goal is to catch problems early, and you can show. Uh, so, like for example, you know, like if you have a website, if I ask you a question, where would you click to book a session? You should not be able to hesitate or click wrong thing. The UI needs to change before development. So that's a vague example, but yeah. So user testing. So user testing means watching real users try real tasks while you observe. You do not you do not explain the UI. You watch and you watch what confuses them. So uh, next we have accessibility guidelines. So accessibility means the interface works for users with different needs, including vision, hearing, motor challenges. Accessibility is not optional. It's a part of good design. Like few, for the scheduler, you could think of you can use high contrast text so it is readable. You do not rely on color alone to show meaning, like red only for unavailable. You make buttons large enough and easy to click. You support keyboard navigation. You provide clear labels or screen readers. uh, yeah, and so UX design and makes the system easy to understand and easy to use. So evaluation through prototypes, user testing catches problems early, and accessibility makes sure everyone can use the system. Yeah, that's all for these topics.